Today we're going to be continuing with trigonometric identities. Last time we talked about 3 different groups of trig identities, and today we're going to add 2 more groups of these identities to our list of identities that we know. So the 2 groups that we're going to add on today are cofunction identities and even-odd identities. So we'll start with the cofunction identities. Now, I'll write the first one out here first. Sine of pi over 2 minus x is equal to cosine of x. Now, you might be wondering, where's this pi over 2 coming from? This is actually the angle measure in radians instead of in degrees. So maybe just off to the side you can write that pi over 2 is just equal to 90 degrees. And similarly, cosine of pi over 2 minus x is equal to sine of x. So notice here, you can just switch sine and cosine. Now the name of these identities, cofunction, means that the ones that are paired together are going to be each function and its cofunction, so sine and cosine. The next one is going to be tangent of pi over 2 minus x is equal to cotangent of x. And then cotangent of pi over 2 minus x is equal to tangent of x. So again, tangent and its cofunction, which is cotangent. And then lastly, we have secant of pi over 2 minus x equals cosecant of x. And then cosecant of pi over 2 minus x equals secant of x. Okay, and then the last set of identities are the even-odd identities. And just like you know about even and odd functions, where even functions, when you plug in the negative value, you get the same value for y. So if you remember when we talked about functions being even or odd, if you plug in f of negative x, and if you get f of x back, you know it's an even function. And if you plug in f of negative x and you get the exact opposite, negative f of x, that's an odd function. So similarly here, sine of negative x is equal to negative sine of x. Same with its reciprocal, cosecant of negative x is equal to negative cosecant of x. So that means that sine and cosecant are odd functions. Next we have cosine. Cosine of negative x is equal to positive cosine of x. That means this is even. Then we have secant. It's reciprocal. Secant of negative x is equal to secant of x, so that also is even. And then we have tangent of negative x equals negative tangent of x. And its reciprocal, cotangent negative x is equal to negative cotangent of x. And so tangent and cotangent are, like sine and cosine, going to be odd functions as well. So really all we're doing today is just introducing more trig identities for you to use. We will be using them in the same way in the context of proofs. And so we'll just do a couple of examples together. We'll use identities that we learned today as well as identities from last time. Okay, so example 1, again we are proving sine of pi over 2 minus x over cosine of pi over 2 minus x is equal to cotangent of x. Again, pick a side to start with. I, again, always start with the more complex side. It's easier to simplify something than it is to complicate something until it looks exactly how you want it to look. Okay, so start with the left-hand side. That's given. And now we can, once you see that pi over 2 minus x, you should start thinking, okay, maybe a cofunction identity would be helpful here. And so the cofunction identity to replace for the top would be cosine of x. And in the denominator, we would replace that with sine of x. So that's using cofunction identities. Now we have cosine over sine, and that should look familiar. That looks like we can use a quotient identity, and cosine over sine is equal to cotangent of x, which is exactly what we wanted, right? If you look back at the problem, that's what we have on the right-hand side. So that's it for that example. Okay, let's do another one. Prove that tangent to the fourth is equal to tangent squared times secant squared minus tangent squared. Okay, I'm going to start with the right-hand side because that looks more complicated. And that's given to us. Now where do you go from there? Now one strategy that can be helpful is you can use the strategy of factoring. So in this case, because we have a tan squared in the first term and a tan squared in the second term, we can pull that out. And I know that's going to probably get me closer to what I want, because at the end I want to get tangent to the fourth. So then all that's left for me to do is to figure out how to get what's in parentheses to equal tan squared. So here I'm just factoring. And now we're just thinking, okay, how can I make that secant squared minus 1 equal tan squared? That's what I needed to equal in order for us to get tangent to the fourth power. Well, I see secant squared and I see a 1, so maybe I'll take a look at the Pythagorean identities. So the Pythagorean identities says that secant squared can be replaced with 1 plus tangent squared. So that's what I'm going to do here. And what's nice about this is that now you can see the 1 and the minus 1 will now cancel. And that leaves us with just tangent squared. And now all we have to do is multiply those together. So tan squared times tan squared is tangent to the fourth, which is the left-hand side. Okay, we have one last example. Okay, prove that sine cubed cosine to the fourth is equal to cosine to the fourth minus cosine to the sixth, all in parentheses, times sine of x. Okay, so for this problem, you might have a hard time figuring out, well, which, the left-hand side or the right-hand side, should I start with? So if you're having trouble trying to figure out which side maybe is more complex or more simple, I would say look at how many terms you have. On the left-hand side, we really just have one term, right? It's just one term multiplied together. There's no plus or minus in there. But on the right-hand side, this looks a little bit more complicated. So let's go ahead and start with the right-hand side. Okay, so that's given. Okay, so now where do we go from here? Well, since we do have, if you look just inside the parentheses, we'll deal with the sine of x later. But inside the parentheses, we have two terms, and they each have cosine to the fourth within each term. So I'm going to do that same strategy that I used in example 2, and I'm going to factor out cosine to the fourth. That leaves me with 1 minus cosine squared. Okay, now that I see a 1 and I see a cosine squared, now I might be thinking, oh, maybe a Pythagorean identity would be helpful. So we know there's a Pythagorean identity that says sine squared plus cosine squared is equal to 1. So I'll replace that 1 with sine squared plus cosine squared, which will help us eventually eliminate the cosine squareds. Okay, so now we eliminate cosine squareds. Just say we're simplifying there. And then here, we're actually practically there, right? Sine squared times sine is sine to the third. So this is exactly what we have on the left-hand side after multiplying. The order's switched around, but we know that when it comes to multiplying, it doesn't matter the order in which you multiply, so that is the left-hand side.